Did you know that NASA might soon need to send SpaceX's Crew Dragon to rescue Starliner crews due to hidden flaws in Boeing Starliner? Yes, you heard it right. Let's get started. Boeing Starliner spacecraft, long anticipated but plagued by delays, finally made a successful launch and docking with the International Space Station, ISS, last week. Despite this achievement, concerns have emerged about its readiness for the return journey due to critical issues that could jeopardize the mission, potentially necessitating a rescue by SpaceX's Crew Dragon. In this episode, we'll dive into these concerns and assess whether Starliner can safely return the crew or if a rescue mission is on the horizon. Initially proposed as a strong competitor to SpaceX's Crew Dragon under NASA's Commercial Crew Program, Starliner now faces a situation where it almost seems like SpaceX might need to come to its rescue. This may sound ironic, but given the current issues with the Starliner, including helium leaks and thruster failures, there's a real possibility that the spacecraft may not be able to complete its return mission safely. If the helium leaks worsen or the thrusters fail to perform as expected, the spacecraft could face difficulties during undocking, re-entry, or landing. This raises the question of whether SpaceX's Crew Dragon might need to step in for a rescue mission. The Crew Dragon is fully capable of performing a rescue mission if needed. It has a proven track record of successful missions and is well equipped to handle emergency scenarios. NASA and SpaceX have contingency plans in place for such eventualities, and the Crew Dragon could be rapidly deployed to rescue the Starliner crew if required. A rescue mission would involve several procedural steps. First, Crew Dragon would need to launch and dock with the ISS, a process it has performed successfully multiple times. The Starliner crew would then transfer to the Crew Dragon for their return journey. This process, while complex, is well within the capabilities of the Crew Dragon and its support teams. Boeing received a substantial $4.2 billion contract, later increased to $5.1 billion, to develop the spacecraft. This investment was significantly higher than SpaceX's $2.6 billion contract. Despite this, Boeing's delays and technical difficulties meant that SpaceX successfully launched the Crew Dragon in May 2020, while Starliner struggled to meet its milestones. The Starliner program has experienced more than 4 significant delays, each caused by countless technical issues. The first uncrewed test flight in December 2019 revealed serious software malfunctions that prevented the spacecraft from reaching the ISS. A second uncrewed test in May 2022 aimed to resolve these issues but encountered additional problems with the reaction control system thrusters and parachute system. These recurring issues drew criticism from both the space community and the public, raising questions about Boeing's ability to deliver a reliable spacecraft. Last week marked a significant milestone for Boeing as the Starliner successfully docked with the ISS, carrying astronauts Butch Wilmore and Suni Williams. This event was met with applause from the space community, eager to see Boeing overcome its previous challenges. Despite the successful docking, immediate post-launch assessments revealed critical issues that could jeopardize the return mission. 5 helium leaks were identified, posing a potential risk to the spacecraft's ability to complete its return journey. Additionally, one of Starliner's reaction control system thrusters, which provides essential maneuvering capability, remained inactive. These problems raised concerns about whether the Starliner could safely undock, re-enter the Earth's atmosphere, and land without incident. Helium leaks were among the first issues to be identified. Initially detected before launch, the problem was managed by closing the helium manifolds during the flight to prevent further loss. However, upon reaching orbit, 2 additional leaks were discovered, necessitating a reassessment of the spacecraft's readiness for the return mission. Engineers calculated that despite the leaks, Starliner had sufficient helium to support its operations during the return trip. Ground teams continue to monitor helium levels closely to ensure there is no further risk. The reaction control system thruster failure presents a significant challenge for the return mission. These thrusters are crucial for maneuvering the spacecraft during undocking, re-entry, and landing. One of the thrusters remains inactive, and ground teams plan to fire all 28 thrusters after undocking to gather additional data. This step is critical to confirm that the remaining thrusters can effectively control the spacecraft during the descent and landing phases. The first uncrewed test flight in December 2019 highlighted major software issues. A malfunction related to the mission elapse timer caused the spacecraft to miss its orbit insertion burn, leading to an 11-hour mismatch and preventing Starliner from reaching the ISS. Another software error involving the thruster valve mapping posed a risk of catastrophic failure during the disposal burn of the service module. Boeing addressed these issues by conducting a comprehensive software review, adding filters to prevent incorrect polling of the mission elapse time, and correcting the thruster valve mapping error. In the second uncrewed test flight in May 2022, problems with the parachute system were identified. A faulty connection caused one of the three main parachutes to have a lower than expected stress limit. This posed a significant risk, as the failure of one parachute would increase the load on the remaining parachutes, potentially endangering the safe return of the crew capsule. Boeing redesigned the soft link joints and conducted extensive testing to ensure the reliability of the parachute system. To address the helium leaks, Boeing implemented a plan involving the careful monitoring of helium levels and closing the manifold to prevent further loss while the spacecraft was docked. Engineers are confident that the spacecraft has sufficient helium for the return trip, assuming no additional leaks occur. As the undocking day approaches, the crew and ground teams are conducting final preparations. The first step involves ensuring that the docking mechanism disengages properly. This mechanism, which has kept Starliner securely attached to the ISS, must be carefully disengaged to allow the spacecraft to drift away slowly and safely. This disengagement marks the beginning of Starliner's journey back to Earth. During re-entry, the spacecraft will slow down from orbital velocity, and once in the atmosphere, the forward heat shield will be jettisoned. 2 drogue and 3 main parachutes will then slow Starliner's descent further. Assuming a successful touchdown, Starliner will be certified as an official commercial crew vehicle, with the first operational crewed mission planned for 2025 under NASA's Commercial Crew Program. SpaceX's Crew Dragon, awarded a $2.6 billion contract under the same NASA program, successfully launched its first crewed mission in May 2020. Since then, Crew Dragon has completed multiple missions both for NASA and private customers. The spacecraft has proven its reliability and capability, setting a high standard for commercial crew vehicles. Boeing faces a challenging path forward to ensure the Starliner program's success. Addressing the current issues with the spacecraft and demonstrating its reliability in future missions will be key to securing its place alongside SpaceX's Crew Dragon in NASA's Commercial Crew Program. Boeing must continue to refine its technology and processes to meet the high standards required for safe and reliable space missions. The recent successful launch and docking of Boeing Starliner marked a significant achievement for the program. Yet, critical issues threaten the return mission. The spacecraft faces challenges with helium leaks and a thruster failure that could jeopardize the crew's safe return to Earth. While Boeing is taking steps to address these problems, the possibility remains that SpaceX's Crew Dragon might need to step in for a rescue mission. Before we wrap up, just a heads up, I've uploaded a video about next week's Falcon Heavy launch. It seems it hasn't reached many of our viewers, possibly due to a new thumbnail design I tested, but I suggest you all watch that video. You can find the link either at the top right corner of your screen or at the end screen of this video. Thanks for watching today's episode. Don't forget to subscribe and give us a thumbs up if you enjoyed it. Stay tuned for another great video tomorrow.